what I'll be talking to you guys about today is MPI support in Parsl and Globus Compute. So this is a slide from 2023. Last year, we talked about how MPI is hard. So this is easy. You want to stick one MPI app inside a big batch job. If you want to stick a bunch of MPI apps with the same size, the same geometry inside a batch job, you could do it. It's a little bit of a hack, but Parsl supported that. And this, on the other hand, was too difficult to do. You couldn't do this. So this is what I want to talk about. So this is now possible. So what I've got here is basically a sequence of different configurations that a single batch job can support over time. So in the first case, as we are starting up, we say that we've got a batch job with 8 nodes, and we try and stick in a bunch of MPI applications with varying node requirements. So just please note that in all of these cases, we are never slicing a node. We are only putting in multiples of a node into a single batch job. That is a limitation. In some cases, you might see that, depending on what is available on the queue of ready tasks that you could run, there might be a node or so idle. But as apps finish and more nodes become available, we fill the batch job back up to capacity with the biggest job that you can fill in that will consume the available nodes. So the point here is to show you that a single batch job can now serve multiple MPI apps with different geometries a long time. So you can arbitrarily stick different apps and we'll support that. So how do we do this? So the first step to all of this is the MPI executor. And I've got little highlights in the configuration. Oh, sorry, forget that slide. This was from the previous Parsl Fest. So this is what we had last year. And this is the updated changes. So you've got the MPI executor, and this is tested on Polaris. So this is tested, it works on Polaris. There are a few bits here that I want to highlight that people notice. So the first bit is this keyword R called max workers per block. This sets how many MPI applications that a single batch job can execute concurrently. Again, it doesn't mean that many will run. It is the maximum number that can be supported. Parsl will internally run the appropriate number of workers to allow this to happen. So even if you have 1,000 nodes, you have to specify how many MPI applications that you want to stick in there. The second thing is that you need to specify an MPI launcher. So this can be either restaurant, AP run, or MPI exec at this point. If you have other more exotic things that you would like us to support, please come talk to me, let me know. The next bit is that unlike other providers set up with a launcher to launch our workers onto every node, we want you to specify a simple launcher always when you're using the MPI executor. This is to make sure that we launch workers the right way for MPI. So now that you've got this configuration set up, what you need to have is you need to specify the resource specification, and in this case, a resource specification that is MPI aware. So what you would do is you would specify how many nodes you want, how many ranks per node, number of ranks, multiple ways to specify this. And then when you call the application, which has this little Parsl MPI prefix attached to the front of the actual command that you want to execute, you pass the Parsl resource specification along, and Parsl will make sure that we will get the right geometry provisioned from the block, and it will also give you the right incantation for the launcher to then have your MPI application launched with that geometry. So that is basically what you need to go for MPI in Parsl. I'll go really fast. So the second part is MPI support in Globus Compute. So the first bit is shell functions. Shell functions are new, and I need to mention this because this is required for MPI functions in Compute. So the first bit is that now you have this new construct called a shell function. It basically allows you to specify a command line string that compute will execute on the remote end for you. So this basically just echoes a bunch of strings on the remote side. Now you can extend this with MPI functions in compute, where you specify the resource specification, just like in Parsl. You would specify the resource specification as a dictionary, and then set that as an attribute on the executor itself. So you set the executor to whatever resource specification you want, run a function. You want to change it, change the resource specification on the executor and run the next function. So that's basically all you need. Unlike Parsl, where you need to explicitly put in the MPI prefix, the MPI function in compute does that for you. There is automatically a prefix attached to your function. So whatever you give will get launched.